And I also record, please be aware. Okay. So as Monica mentioned, I'm at the Technion in Israel. In the recent years, my main funder of my research is the Israel Science Foundation. And I will talk to you about meta reasoning. As Monica mentioned, I sit at the Technion. This is my affiliation. The Technion is a technical university similar in the style of university to MIT in the United States. I'm in the Faculty of Industrial Engineering, which means I live in a world of interdisciplinary research, which enriches me a lot. And I'm the head of the program of Behavioral and Management Sciences, which has several graduate programs within the engineering school, which provides the students with enrichment across the world. We combine in our students' research data science, computer science, statistics, engineering, etc. In our group, we have a cognitive psychology and human factors engineering program. We have organizational behavior and behavioral marketing, all with association to industrial engineering, but we also, of course, do basic research in psychology. I'm in the cognitive psychology track, and I like this combination that this unique program allows. In this talk, I would like to give a brief introduction to metacognition in case somebody would like to refresh the terms, but I will focus on meta-reasoning. I will talk about bases for self-assessments, the metacognitive judgments, with the main claim that self-assessments are reliable to the extent that the cues people rely on are reliable. I will aim to give you two empirical examples from two different studies, one about the brief judgment of solvability. Sorry about this. I will explain, of course, what it is and what cases we have it, and biases and bases for this judgment. And I hope that time will allow also to provide you with a brief review of a very recent paper about metacognition of ill-defined tasks, which is severely understudied. The background, as Monica mentioned, the metacognitive research traditionally focused on learning and even more focused on memory, which means that like 90% of the research domain deals with memorization of words or with retrieval from memory, like answering knowledge questions. But the principles of the metacognitive framework are clearly relevant to other tasks as well. So together with Valerie Thompson, my colleague from Canada, we adapted this framework, adapted the same principles to the reasoning context. Valerie Thompson is an expert in reasoning, in particular in the dual process theory line of research, and together we merged our research domains to generate the meta-reasoning framework. Recently, this book you might know from Heidelberg, together with Klaus Fiedler, we wrote a chapter which gives an introduction for students about the domain of metacognition and includes both meta-memory and meta-reasoning and decision-making as well. So it's open access, feel free to download and get it. The classical meta-memory paradigm looks like this. It involves word pair memorization. Participants get an empty screen, they press a present button, they get a pair of words and press the continue button. We measure study time between the two key persons, and then we ask participants what is the chance they expect to recall their right word when presented with the left word. And in my studies, I use a continuous scale like this one, and this is the judgment of learning. So we measure study time, judgment of learning, and of course, they study like 60 pairs, and in the recall test, they get the left words and should come up with the right words. And then we assess accuracy, of course. So we have three main measures: accuracy, study time, and judgment of learning. When we look at metacognitive mental effort regulation, and we have this framework or this methodology in mind, learning means mainly memorization, which means that people get information from the outside world, and they would like to have this information ready in their mind whenever they want to use it. Sometimes, if they retrieve information and get knowledge from their memory, then the arrow goes at the other side. The metacognitive monitoring is the constant assessment, what is my chance of success, and the control are the regulatory decisions people take, whether to rethink, move on, seek help, etc. When we consider problem solving, everything remains the same. We have knowledge. We might increase our knowledge by attempting to solve some problem, and we might use our knowledge to solve the problem. Also, we ask ourselves all the time, what is our chance for success? And we should decide whether to rethink, to move on, to seek help. Everything is relevant here as well. This is the smooth integration between the domains. So in both domains, meta-memory and meta-reasoning, reliable metacognitive monitoring is a key for effective effort regulation. If we have a bias in the monitoring side, our control decisions will be biased. And I'll demonstrate it with empirical findings. The problem is that monitoring is prone to biases. And this is a challenge we all face with, and we would like to know what are the conditions under which the monitoring is more or less reliable. Examples of reasoning tasks. For example, this one is the compound remote associate task. Sometimes there is a similar task called remote associate test. In both cases, there are 3 words, and the task is to find a 4th word, which generates a phrase with each of the 3 words. Here, the answer is cheap. This is an easy item. Another example is the Raven matrices. Here, there are rules in the lines and in the columns, and the task is a multiple choice test with 8 options. Another classical task in the reasoning domain is the syllogism or conditional statement, in which there are 3 parts to these sentences. If a car something, then something, the car, given the car is under some condition, what can I infer? And this is a yes-no task. Another example is the classical cognitive reflection test. Ackerman used it, like the misleading math problems here. And in this case, it's a math problem, so people should insert a number here. In the talk, I will refer to the Raven matrices in the examples I chose to give today. And also, I will hope to get to the creativity task, which is an ill-defined task. Unlike all those tasks which have a correct answer, creativity has no correct answer. And this is a challenge for metacognitive research. By the way, I don't see the chat. So if there is anything in the chat, please let me know. Oh, I see Joachim shared the link. Okay, good. Thank you. Okay. So the meta-reasoning framework. Here, the timeline is from the top to the bottom. And we see here the classical components, sorry about it, the classical components of a reasoning flow. You must with each of the examples you may choose from the previous slide, you must identify what are the components, given components, and the goal in the task. Then there might or might not be an initial response, autonomous response that comes to mind immediately, but it's not necessary. Sometimes we engage in an analytical processing in addition or instead of this autonomous response. And at the end, we have an answer choice. So there is no argument against this very, very general structure of a reasoning flow. In parallel to this timeline, we suggest that there are monitoring and control processes, like in learning and memory. In this case, we examined or came up with the list of monitoring types we found in the literature or generated in our research. And there are a set of metacognitive control decisions that are hypothesized to be connected or stem from each of these judgments. For example, the initial judgment of solvability should guide us in the decision whether to engage in solving or just give up because it seems to be not solvable at all. The meta-reasoning framework generated a community, and I would like to invite you all to this community. If anybody would like to join, first you might examine this website, in which I maintain the list of all the papers I know of. Amory Danek just sent me a recent paper. Congratulations, Amory, for your recent, just published paper. And here she is, I see her. Oops, okay. And in this website, we manage a community. There is a mailing list and updates. So if anybody is interested, just send me an email and I will be very happy to add you there. I don't know why it jumps like this, but okay. So when we consider the meta-reasoning paradigm, the most similar paradigm to the meta-memory paradigm is the compound remote associate task. Here, instead of 2 words in the paired associates, we see 3 words, and the rest is very similar. Participants should enter here the word. We measure response time between 2 clicks here, and we ask for confidence in this case, or initial judgment of solvability, or ongoing confidence, etc., all the judgments. But this is, in this example, we see the final confidence. And of course, we examine the accuracy of the answers. So we have the basic 3 measures of success rate, final confidence, and response time in this case. So effort regulation, when I talk about effort regulation, it's in fact, in this case, the response time, mainly. So we triangulate all these measures, and we have a set of measures that can be stemmed from these, like efficiency, for example. Efficiency is the association between success rate and response time. How many correct answers you provide in a given amount of time. So if we look at the figure here, confidence in this example is here, and response time encompasses all these decisions that take place throughout the reasoning process. Today we'll talk about initial judgment of solvability, which is here, and originality judgment in creativity task, which was not there in the 2017 paper. In this 2017 paper, in which we introduced the meta-reasoning framework, we presented 6 questions. Today, I will talk about the kinds of judgments. As I already hinted, we add also the originality judgment, which was not there at 2017. And of course, there might be many other judgments. And we ask what factors underlie each of the judgments, and I will demonstrate this as well. So when we talk about the challenge of effective reasoning and regulation, one of the challenges is that assessing difficulty is really a challenge in itself. While word pairs, you might consider whether the words are related immediately. You might consider whether the objects are concrete or abstract. But here, when I get three unrelated words or just a few figures on the screen, how can I assess whether it's a difficult task or an easy task? If it's a very difficult task, I might consider whether I would like to engage in it at all, or I might skip and go on to the next one, which will be easier to me. But how can I know it? Moreover, beyond the difficulty which might involve a challenge, a problem might be not solvable at all. If I take here just a sequence of three random words without any common association, then there is no solution. But how can I know it? This is the challenge of judgment of solvability. In word pairs, any word pair, if you invest enough effort, you will remember it. Young and healthy adults, at least. But this might be not solvable. And this is relevant to many situations in life. An engineer might get a challenge to combine some materials in a way that is not solvable at all. If I have to build a bridge across a river and there is no available material to do it, then it's not solvable. I better acknowledge it as soon as possible. Okay. There are indications that people invest a lot of time on non-solvable problems. They find it very hard to identify them and they waste their time. So effective reasoning regulation should allow us to cut down this labor in vain, this non-effective time that we invest. So reliable metacognitive monitoring, as I said before, is a key for effective effort regulation in meta-reasoning, of course, as well. However, here as well, there are biases. In a previous study already published by Tirza Luterman, it's part of her PhD. She just graduated, by the way. Those who know her, she is a Dr. Luterman now. I see some happy faces. So she studied the initial judgment of solvability, and I will go with you quickly over her study. She presented only the 8 figures of Raven matrices without the answer options and asked people to respond in 4 seconds whether the problem is solvable or not. Wow, how can I know it? And how did she make those which are unsolvable? So half of the problems were the same original problems, just she reordered the items. So now it's not solvable at all because there is no rule that can be satisfied by a single figure here. Would you differentiate between these two? I see some brows, some eyebrows raised. Okay, it seems almost impossible, right? So I will spoil the story and say that with four switched figures, they didn't differentiate, but with 2 only, and then it's more similar, and then they distinguished between solvable and unsolvable problems. This is a fascinating finding. Okay. So they had in 4 seconds in which you cannot solve such a problem to state whether they assess that the problem is solvable or not. Then after looking at 30 matrices like this, half of them solvable and half not, they had unlimited time to attempt solving with the answer options. But they could also press a button to state that this one is unsolvable. So this is the final judgment of solvability. The initial assessment whether the problem is solvable in 4 seconds is the initial judgment of solvability, as written here. But after the solving attempt, they again decided whether there is a solution or this is an unsolvable problem. So there is also a final judgment of solvability. And our question was whether, or to what extent, or under what conditions, this initial judgment of solvability predicts response time, thinking time here in the unlimited time, and the final decision whether this is solvable or not. The main findings from the previous study were that the initial judgment of solvability was not reliable in this condition of 4 switches, 4 figures switched, but the initial judgment of solvability uniquely predicts solving time after controlling for difficulty and actual solvability, of course. So if I thought at the beginning that this is solvable, I invested longer time attempting to solve it. Then if I thought it's not solvable, then I gave up on it more quickly. So here we see an example of a biased initial judgment that misleads the effort regulation that comes afterwards. And this is the causal link we would like to see when we study effort regulation. Okay. Now I would like to tell you about the next study, which is in final stages of preparation now, about the initial judgment of solvability and its predictive value to response time and final judgment of solvability. So we saw that it predicts, and now we would like to delve further more into underlying processes of this initial judgment of solvability that takes place in 4 seconds. So the previous study, the published paper, was about a judgment which takes place we ask about those judgments that take place throughout the process, and we saw the judgment of solvability in the previous paper. Now we ask what factors underlie this initial judgment of solvability. In this paper, it's a review paper in which I give a taxonomy, I would say, which lists bases for meta-reasoning judgments. And I divided them into 3 categories. Self-perception for me as a person, task characteristic about the entire task across everything, and experience during each item I must face and each itemized challenge, whether this particular item is processed fluently, whether it's familiar, whether it's concrete, etc. I'm very interested about interactions among these groups of cues that inform these judgments. Today, I will talk about a task characteristic and an experience during each and every item. In this study, as in the previous one, we use nonverbal stimuli. Overall, nonverbal stimuli is very severely understudied. This one study in the metacognitive research, I mean, it's of course very much studied, but not in the metacognitive research. This is a single study we found in which there is a heuristic cue that might bias judgments regarding problem solving. Here, the same problem was presented visually, either with symmetric presentation or non-symmetric, and they found the symmetry to bias the judgment there. In the present study, we used the Raven matrices. So we ask, how do people infer solvability in the Raven matrices? And one of the inspiring paper, or several papers, is the line of research by Monica and Arndt from your group. about the Q integration in meta-memory judgment. So we thought about the group of Qs about the task. This is the top-down expectancy in this case, and a bottom-up Q which people infer during performing the task. So as information about this task, we provided the participants in the instructions information about the rate of solvable problems among the matrices. They had 30 matrices, and in fact, 50% of them, 15 were solvable, but each group was informed on a different rate of solvable problems, either 2/3, half as it was in fact, or 1/3. And we wanted to see whether this information biases the cutoff in which they decide whether the problem is solvable or not. We used for this analysis the signal detection theory. Here we have the judgment of solvability in this case, and we ask where is the criterion above which they think a problem is solvable. So this is the idea in the case of this Q about the information about the solvability, and let's see the results. We found no difference among the conditions. It's a between subject design. We found no difference in the detail. So the discriminability between the Raven matrices, solvable and unsolvable, was the same. The difference was in the criterion, as we expected in advance. This line was of the 50% case, and we see that people naturally tend to say solvable. The criterion is relatively low on the solvability scale here. The optimum would be here, while they put the criterion here. When we told them that 66% of the problems are solvable, they lowered the criterion to cover more area with answers solvable. And when we told them about the 33%, then they shifted the criterion upwards, and this was closest to the cross between the curves here, and this was the most reliable location of the criterion. So we see an effect of this information provided before the study on the decision, the criterion for the decision people used. We talked about Q integration. So they had this information, and in addition, we had a Q, a bottom-up Q, in each of the items. In this case, we used item nameability, which means we asked another group of participants in a pretest, how easy is it to name the figures here in the matrix without the answer options? Another sample, not the same sample, but in another block, we showed them just these itemized figures here, one by one, and asked them how easy is it to name each one of them. And we examined which we didn't know, and we didn't have an hypothesis here. We just examined which of them predicted better the judgment of solvability. The collection of local figures, or there is some gestalt here that generates feeling of solvability. Okay. So the itemized figures did not predict judgment of solvability, but the entire figure, like this, the entire matrix, did predict judgment of solvability. And we see here the very little differentiation, which is not significant, between the solvable and unsolvable matrices. And we see a strong predictive value for nameability, although, of course, it's not related to actual solvability, since every matrix included the same figure, just messed up. So there is no association between the figures here and the actual solvability, but we see a strong predictive value. So we see here an integration of both Qs. It is a Q integration between the top-down expectancy of the solvability rate and the bottom-up nameability Q. Now, another experiment in the same paper, we wanted to examine generalization to a verbal task. So we got back to the compound remote associate task, because here we could manipulate a similar, very similar factor. The solvability manipulation was just presenting here 3 random words, as I explained before, that had no common association. So the question is whether people can identify these random triads from those that have a common association. Half of the problems were solvable and half not solvable. The top-down expectancy was as before, it's a replication item study. And the bottom-up Q, we wanted again a Q that can be itemized for each word in isolation, right? Like the figures we had in the Raven matrices. So we used the frequency in the language of each of the words. And we aimed to find a replication. And indeed, everything replicated, the patterns are robust. We found again the criterion moves by the information about solvability rates, and we found again a predictive value for the frequency in the language to the judgment of solvability. So we see in both cases Q integration in the quick initial judgment of solvability in both verbal and non-verbal tasks. To summarize this close to submission paper, we see meta-reasoning tools that allow delving into reasoning processes more than done or from a different angle than done before in reasoning research. We see the non-verbal problems which are severely understudied in the domain. This is an example. Currently, I study another non-verbal task, which I find fascinating, and I'm very engaged in this study with visual figures, and it's like geometric figures. In the previous study, we found that initial judgment of solvability is not reliable, but predict solving time. The present study shows that initial judgments of solvability are affected by expectations, bottom-up cues, like shape nameability and word frequency. Okay, Monica, please guide me whether you would like me to continue to the next study or yes? Okay. Okay. So, of course, such a study about effort regulation has practical consequences for you can think about, again, engineering, about students who study, and many other, maybe a doctor who faces a challenge and should acknowledge whether it's not solvable, etc. Okay. So we should know when to give up on challenges. This is the main message. Okay. So since you would like me to continue, I will be happy to do it. So in the 2017 paper, we had the meta-reasoning framework with these judgments and this list of controlled decisions, and all the time we ask what else. And I invite you to ask what else. What else is going on during the reasoning process? And in this case, we chose to focus or to introduce a new judgment, the judgment of originality. This paper is published, recently published, and you may look at it and give us feedback, of course. So we talked about the context of creativity, And as I mentioned before, ill-defined tasks are hardly studied from a metacognitive perspective. And this is a major lacuna I find in our research. When we consider creativity, there is a flow of a creative process. There is originality and novelty that should be taken into account. The ideation process is the cognitive process of generating the ideas, which is very interesting as from a metacognitive perspective of effort regulation. We should encourage flexibility and adaptability. And of course, elaboration and explanation should come there as well. In this study, we focused on the left side of the figure, on originality, novelty, fluency, and ideation. This was the focus we chose here. We used the divergent thinking task, which some of you might know. We presented a picture of a very simple object and asked people to list the original users, or we didn't tailor them original, just users. Please write ideas for users for this object. Here are some examples, okay? So this is a classic task, studied a lot. It's a very useful task, and it's used for many types of research, of creativity research. A relative measure of performance is to compare how original people are relative to other ideas or to other people. Typically, the originality is assessed subjectively. And this is very problematic for metacognitive research because in order to assess reliability of a judgment, we need some objective measure to compare the judgment to. We can measure originality objectively. And this was our aim here in order to compare the judgment to something objective in order to see whether there is a bias or not. Typically, people do not, in this research, they do not assess their own ideas, but give experts to assess their ideas. For example, our research is reviewed by others, and they should assess the originality of our study. Of course, you can think about theater, about literature, etc. All these are assessed by others. But we claim that the others come after the self-assessment of originality. If I would not think that this paper is original, I would not do this research. So I must assess reliably my own originality in order to invest my effort in the correct point rather than waste it on something that is already known. So we can assess to ourselves the originality, and so our study contributes objective measure of originality and focuses on the self-assessment of originality as a metacognitive process. The serial order effect is the classical finding in the originality research that the early ideas, what to do with this bucket, for example, are less original, which means the frequency of an idea is higher in the population. So it's not a rare idea. This is a common idea. So this is the scale here. Frequency is high, which means originality is low. So look, when you think about originality, think about this scale at the other direction. Lower is more original. The later ideas in people's lists are the rare ideas, the uncommon, the original ideas. So ideas later in order are typically more original. In our study, we asked first, are self-assessments of originality sensitive to the serial order effect? Do people acknowledge that the first ideas are less original than the later ideas? Then, are they reliable? How they are associated with actual frequency in the population of participants? Do they reflect an overestimation? Do we think we are more original or less original than we are in the population of participants? And are subjective and objective originality judgments affected by the same factors, or can we dissociate them? Can we find factors that affect originality but do not affect the judgment of originality? And the other way around, can we find factors that affect the judgment but do not affect actual originality? So this was our aim in this paper. We focused about in fluency here. So fluency is the serial order effect, whether it comes to mind quickly or later in the process after struggling with generating the idea. In the first experiment, we had this task. The participants were Technion students, and we asked for each of the ideas, please assess how many participants from the samples of your peers came up with this use you just wrote. So this is the originality judgment. We see here actual originality score. Please appreciate the effort in assessing actual originality in open-ended answers like this. One of them wrote a lamp and another a light source, etc. And they were merged into one idea. So we had students sit and rate they categorized the ideas into groups, and we had actual originality score of the ideas. We see here as some people provided a lot of ideas and some of them provided a few ideas, we did this median split here of early ideas and later ideas for each participant, for each object. And this is what we see here. So we see a replication of the serial order effect. The easy, or the early ideas are less original, more frequent in the population than the later ideas. The question which interests us is whether people over-assess their originality or under-assess their originality. Over-assessment means that the line will be here, and under-assessment means that the line will be here. And this is the finding, which might be surprising to some people since it's contradictory to overconfidence, which is so common. People think their ideas are more common in the population than they actually are. And we associate it with some narcissism, but I think that people think like me, and if they think like me, my idea is not so original. And we see here the serial order effect, which is acknowledged, but with an entire shift to more frequent, to assess ideas as more frequent than they are. So we see under-assessment here. Are the judgments reliable? We see the under-assessment, very strong under-assessment. And can we dissociate them? I will not detail now, but I will tell you briefly that we dissociated, we did a double dissociation. In experiment, I showed you the results of the first experiment. In the second experiment, we used Norbert Schwarz's idea about anchoring. We told them that most people give 2 ideas for each product or 6 ideas for each object. And this affected the performance, the actual ideas they gave, but not the judgment of solvability, of originality. And in experiment 3, we gave them during the training at the beginning feedback either positive, regardless of their actual ideas, or negative about their originality, about 4 ideas that they gave for one object. And then the task was as before, and this affected the judgment, but not actual originality. So they are not affected by the same factors. We have a double dissociation. So this study demonstrates how to study ill-defined tasks with metacognitive tools. To sum up, we have here a list of questions in the meta-reasoning domain. I demonstrated today how to get into the question about what judgments take place here. I also demonstrated how to study what factors underlie the judgments. But we also, I'm very much interested in the stopping rules, how much time people invest and what guides their decision to stop. Monica and I have a paper about it, and I have a recent paper with web search as an example to a reasoning task in which we predicted by the diminishing criterion model, which is a model I published already in 2014, the time to first click in a web search. So when you search the web, you get 8 answer options, and we predicted by the metacognitive model the time that you take until you click the first option to examine more thoroughly. We ask, how does metacognitive analysis support delving into cognitive processes? What can we understand about the reasoning processes themselves? For example, in what conditions people will be prone to errors, like in the bat and ball type of misleading problems. These questions bother the reasoning world for years now, and we shed new light from a metacognitive perspective on these issues. We ask what aspects individuals differ in, either cultural differences, which I study now, or it can be some learning difficulties or many other individual differences. I now study also mindset to intelligence, whether fixed or growth mindset. I'm about to finish writing a paper about it. How can the metacognitive research guide performance improvements? This is the holy grail, and we have very little answers so far. So I call you to look at our website, the meta-reasoning website, and think what else you can be original and contribute to our research. In all these, and of course you may add additional questions as well. Thank you very much, all of you. Monica asked me to show this slide.
Thank you very much, Raqefat, for your presentation. I hope you noticed all the clapping hands that everybody showed you.
A few of them. Thank you.
Great. So now the floor is open for questions. And as you can see on the slide, we prefer that you raise your virtual hand via the raise your hand feature, but you may, of course, also write questions in the chat.
And you will moderate the questions, Monica?
Yes, I will do so.
Thank you. Just please be aware that you are recorded.
Yes. So I will start with a question. I saw that you, and I really like that you checked whether people are underconfident or overconfident in their judgments of originality. But I wonder whether it would be also possible and interesting to check what is called resolution in meta-memory research, to see whether people get at least the differences in originality between items or responses correct. Did you think about that?
We examined it. We didn't include it in the paper, and embarrassed to say that I don't remember, but I will check and get back to you.
Great. So there is a question by Arndt. Arndt, fire away.
Okay, thank you, Raqefet, for this inspiring talk. I have a question a little bit like the devil's advocate here. So of course I was flattered that you cited our work on Q integration. But since I am aware that our reviewers were very critical to ask if we really showed that there was Q integration, I ask you the same question. So especially your expectancy or your expectation thing is maybe not so much of a Q that is integrated during the judgment, but I would rather think of a model that people set some aspiration level due to the situation or the instructions they get. And from there, they only operate by using the other Q. So what we did in our research was that the Qs varied between items, each item. And then we tried to argue, okay, then probably for each item, there is some integration of this information. But here you could also think they just set some limits, some criterion, and from there on, they just look at the other Q. So, you know what I mean? So maybe
yes, but this is the difference in my taxonomy. But maybe I'll go back to the taxonomy. Just a minute. We have the participant level of taxonomy in the taxonomy, then the task level, and then the item. And you talk about the item, the Q integration at the level of the item. While in this study, we examined integration among the levels. So the judgments differed by this criterion between the groups. So my interpretation is that they take the information and incorporate it for each and every item and add the item Q in addition to that information, which they take into account throughout the task. It was 30 problems and it's robust there was no order effect there. So it's a robust information that was taken into account throughout the task and integrated with, in addition to nameability or frequency in the language. So this is the sense of integration I have in mind. In another line of research, I published several years back about screen versus paper reading and problem solving. I think it's also information about the task that was taken into account, and the judgments differ between these environments. Mm-hmm. So in my perception, or another example was with open-ended questions, whether closed, like multiple choice type of questions, and the judgments differ between them. So this kind of global task information is taken into account in each and every judgment, in addition to the Q level Qs. This is the way I see it.
Okay.
Does it make sense?
But yes, it makes sense. Or one could still think about measures to do it item-wise, perhaps. So you could also have, let's say, different types of problems, the ones with, let's say, abstract words and the others with concrete words, and you give information beforehand that one type is easier to solve than the other one. And then you could even find this integration at the item level, perhaps. So by switching the expectation from item to item and the item solvability also. But so this is
I think it's an empirical question whether people can switch this type of information at the item level, but this transfers in the taxonomy from the task global level to the item level. So you might do a study, an interesting study, which compares an information provided about the entire task, which generates top-down expectations, to more itemized information that is given or should be taken into account differently for each item. I think the cognitive process or the metacognitive process should be different, not necessarily the same.
Yeah, let's do it.
Let's do it. I'm here to do it.
Great. So there is another question by Amory Danek. So you should.
Yes. Hi. Hello.
Hi.
Hey.
Good to see you.
Talk. Yes. I have actually a related question to this, because I was trying to think, like, how could we actually investigate all of these 3 levels of cues together? And I would assume that it's also task dependent whether each level, how relevant each level is. For example, maybe for math problems, self-perceptions like anxiety, I'm not good with numbers, may play more of a role compared to other tasks where the self-perception may not play any role at all, because maybe I've never encountered any task like this. So how can we actually, how will we be able to disentangle all of this? I mean, it's really difficult to, we can go on and search for individual cues, but we would need cues from all 3 levels, ideally. And yeah, so I'm just...
This is your path to professorship, I think.
Yes. I would be interested to hear your thoughts on that.
Unfortunately, studying these heuristic cues is a very, very demanding task, because the cues differ in their effects. So we must go, people talk about fluency, but fluency, for example, encompasses so many types of fluency. And people find some kind of fluency to affect some situations more or less. So I don't see another option except for searching for biasing cue, which is the methodology to identify cues, and consider under what conditions they are reliable and actually predict performance, and under what conditions they are biasing. Please note that all these studies about biases, they generate in many of them, they generate some artificial situations. Mm. Although I aim in my research to do the biasing factors as close to real life as possible, as you saw here, when manipulating the, using, for example, the frequency in the language. It's something that really exists. Or in another line of research, we use the study materials with or without illustrations. That this is the way our books in schools look like. So I try to use examples as close to real life as possible, but sometimes it's very artificial, like mixing up the Raven matrices component. No psychometric test will do that. But as I mentioned, in real life, there are unsolvable problems, and we don't teach the children to cope with them at all. All the problems in all the exams are solvable, but in real life, there are unsolvable problems, and we should consider how people can identify and avoid or lessen the waste of time on them. So I'm afraid that we have to work hard on each and every possibility and consider the conditions, and this is our life as cognitive psychologists.
A lot of work.
Okay, Edgar Erdfelder has a question.
Rakafi, thank you for this very stimulating talk. I'd like to raise a question that relates to metacognition research in general. So an implicit assumption that we always have in metacognitive research is that the metacognitive judgment tasks are non-reactive in the sense that they do not affect behavioral responses later on. In other words, for example, in meta-memory research, performance in a memory task does not depend on whether or not I was previously asked for judgments of learning. Now, there is some literature showing that this assumption, at least in the meta-memory area, is wrong. And for me, this raises the question, might a similar problem occur for meta-reasoning research? In other words, can we be sure that the meta-reasoning judgments do not affect later, well, reasoning judgments?
Okay, so thank you for this question. I also share your concern, and there is a line of research, Double and Birney, who show about Raven matrices that judgments, I think confidence, is reactive and they found that it improves performance. And at the initial stages, they just published papers that show that a phenomenon without any theoretical explanation. Now in the recent years, they wrote, the same team, Double and Birney, they wrote several papers in which they attempt to explain under what conditions there are effects of reactivity and when there are not. I must say that I was not convinced that now I know when there are effects of reactivity. The way I address this concern is that every new task that I start in my lab, I start by a pilot study with and without the judgment I collect. And I make sure that I use only, it sometimes differs among the stimuli. I don't understand why, I don't have any theoretical understanding. Any contribution in this will be highly, highly important. The way I address it is I start, I do the pilots, and I make sure that in my materials there is no reactivity. So this is the very poor answer I can provide for this very important note.
Thanks.
Great. Are there further questions?
Just I would like to also add to Edgar's question also that there is a publication bias in this domain, that people publish with a title of reactivity, only those cases in which there was a reactivity. But in my studies, since this line of research started and I was not satisfied with the theoretical contribution, I make sure to write in all my papers about the pretests I did in which there was no difference, in order to have some meta-analysis in the future include also the non-reactivity findings.
This is in fact a very interesting question. Do you know of any meta-analysis that tests for selective publication in that area?
I know about judgment of learning, that there was one. Monica, do you remember the details?
Yes, there is a meta-analysis, but right now the problem in this subfield of research is that you can't publish anything because they're competing hypotheses, and unless you have an experiment that is well suited to test all hypotheses out there exactly at the same time, reviewers will say, yeah, okay, but it's not a real advance. So I think that there are, and sometimes findings are not perfect, and this tends to be rejected too. So I think that there might be a publication bias, or just, yeah, I think that there's a lot of work not published right now because it's difficult.
Yes.
Great. So I have one more question, and I was puzzled by your finding that judgments of solvability for the compound remote associates did not always differentiate between solvable and non-solvable problems, because did they have 4 seconds? No, that was with the raven. So I was thinking, shouldn't they be able to get some differentiation at even if only based on intuition?
Thank you for this question as well. Topolinsky and colleagues, several colleagues, Strack among them, had a long line of research in which they showed that they call it coherence judgment. They didn't ask about solvability. We used their idea to generate the unsolvable problems, just put the words, random words. But they asked about coherence while we asked about solvability. We have a paper, Ackerman and Beller, 2017, in which we addressed this question. We didn't empirically examine the comparison between coherence judgments and the confidence or initial judgment of solvability. But in the discussion, we raised the option that these are not exactly the same. That they ask about coherence, which might be more based on gut feeling than the question about solvability, which we compared between asking whether the problem is solvable to whether you can solve this problem. And we found no difference between them. So it might be that people take more seriously the question about solvability, or they imagine themselves solve the problem, while in coherence it doesn't, they are not asked about it. They even don't know exactly what they are asked about. There is no attempt to solve or to guess the solution. So I think these tasks differ, but this is an open question for research.
Thank you. So, any further questions? Okay, so this is your very last chance to ask a question and have Raqifat answer it.
They don't have to.
No further questions. So thank you very much for your presentation, Raqifat, and thank you very much for answering all the questions that we had. And please hang on for a bit longer.
Okay, thank you very much. It's lovely to see you all. Really, I'm very happy.
Do you want to just stay here? Or do you want a breakout session? I think it's probably fine.
Yeah, I think so.
Now would be the time for a post-colloquium with good food and wine. But everybody has to do it on his own or her own.
Imaginary food.
Sitting together in a restaurant is something you cannot do these days.
I can offer a few cookies. I eat for you.
Thank you.
I only have tea.
Yeah, I can offer some water. Raqifat, thank you again. This was really wonderful, and it was impressive to see how much you have progressed since I've heard this is the current state of the art in meta reasoning research. These were two completely new lines of study, and I really like them very, very much.
Thank you very much.
I entirely agree, and I just got another question, which is very important. The reasoning researchers, do they care? I mean, obviously, the metacognition researchers, they care. They like this kind of research, and the extension over and above memory, meta-memory research. But do the reasoning researchers care?
In fact, the most discussions are with the reasoning world, more than with the metacognitive world, unfortunately. There are people who start, mainly students who studied meta-memory, who, if they find it, the meta-reasoning world early enough, they are intrigued and they start to find their way there. But most of the people in our sessions, we do from time to time invited sessions or session about meta-reasoning as a sequence of talks. Most of the people are from reasoning world. There is a group, very nice group, which meets typically every year in London, which is called London Reasoning Workshop. And it's entirely reasoning group. I'm the only metacognitive group, and they accept this research just amazingly. And they just hug it and cite it and take it into account and add confidence to the experiments. And it's very nice.
That's good. Good to hear.
Mm-hmm.
What time is it in Haifa right now?
7:30 p.m.
Oh, okay, so
we just moved to the winter time a few days ago.
1 hour ahead. So
yes. Okay.
So
it's lovely to see you all.
Same with us. Thank you for visiting us and giving a great talk. Hope to meet you again. Next time.
Thanks for coming to my home. You're mostly invited. Only Monica was here already. You are all invited.
Oh, thank you very much.
Yeah.
Bye, Rakafe.
Good evening. Bye-bye.
See you.
Bye.
Bye.
Bye-bye.
Bye-bye.
Thanks.